Hello everyone, I am Dr. Rajesh and today we will study the question based upon the properties of various operators that we have studied. And this question I have picked because this question gives the contrast that this thing delta square by E x cube is not equal to delta square x cube by E x cube. So both are different questions. So I'll show you that why they are different and where they differ. Firstly, let us take the first question, that is delta square by E. So that means let us try to understand here. That means these two operators are operating upon the operand x cube. This operand is not distributive upon this operator, like that it will be written something delta square x cube E x cube. So this is not possible. So this is, I'm removing it. Fine. So here it means that it can be written as delta square E minus inverse shift operator, and that is x cube. It can also be, there is no compulsion that we have to write E inverse first and then this. No, there is no compulsion, such compulsion. You could also write it as a, in both the cases result will be same. So I will show you. This will be delta square E minus x cube. Fine. And you know this thing is equal to delta square E minus, you know, is equal to inverse shift operator is equal to x minus 1 cube. Fine, because you will write E inverse is equal to E inverse acting upon f of x, where h being the interval of differencing is nothing but f of x minus h. So here instead of this, here f of x is equal to x cube and h is equal to 1. Therefore E minus x cube is nothing but f of x minus 1. So here x minus 1 will be x minus 1 cube. Done. So I have written over it, in place of this one I have written x minus 1 cube. Now delta square will operate like 1 by 1. So firstly, applying delta one time, this will be x minus 1 plus 1 minus x minus 1 cube. This to this will cancel out. This is delta, because you will also mention that f delta f of x is equal to f of x plus h minus f of x. Fine. So this you will also mention over here. This will be x cube minus x minus 1 cube. So open the cube now, x cube minus, open this one, x cube minus 1 minus 3x x minus 1. Fine. This is further equal to delta x cube minus x cube. This will be plus 1. This is minus 3x square and minus will be plus 3x square. It is minus, minus is plus, so this will minus 3x. So this will cancel out. This is further equal to delta 1 plus 3x square minus 3x. Done. This will be delta 1 plus 3 delta x square minus 3 will be out, this will be delta x. Delta of a constant is 0 plus 3. Delta of x square will be x plus 1 whole square minus x square. Minus 3, delta of x will be x plus 1 minus x. Fine, this will cancel out. So this will be 3. It will be x square plus 1. It will be plus 2x minus x square, and it will be minus 3. X square to x square will cancel out. This will be 3 plus 6x minus 3. This to this will cancel out. So we are left with 6x. This implies that delta square by E is equal to x cube is equal to 6x. Similarly, if you will see, the result from this will also be the same. So if you want me to do, so I could also get it done. So now I will show you the result from this one will also be same. So we'll try it with this one. So writing this as E minus delta square x cube. Fine. So this can be written as E minus 2 times delta. Fine. 1 by 1 it will apply. Now we have to find delta x cube. This will be E minus delta x cube. 1 is the interval of difference. It will be x plus 1 cube minus x cube. Done. So this will be E inverse delta. This will be x cube plus 1 plus 3x plus 3 x square, opening this x plus 1 cube minus x cube. This will cancel out. Fine. E minus delta, it will be 1 plus 3x plus 3x square, done, is equal to E. Now you know delta is distributive, so it will be delta 1. 3 will come out. 3 delta x plus 3 will come out delta x square. This will be E inverse. Delta of a constant is 0. 3 of delta of x is this one. Delta of x square is x plus 1 whole square minus x square. Fine. X to x will cancel out. This will be E minus 3. This will be plus 3. Now open the square, x square plus 1 plus 2x minus x square. This will cancel out. So we are left with E minus 3 plus 3 plus 6x. E minus is equal to 6 plus 6x. Done. So this will be E inverse of 6 plus E inverse of 6x. This E inverse of a constant, because it try to shift, you know, E inverse f of x is nothing but f of x minus h. But in constant quantity, the constant quantity will not change. If here is some constant c, this will again be c. So here 6 is c, so this will be 6 again. And you know, in this 6 will come out, and you will write the E inverse operator upon x. Done. 6. And you know, when it is applied upon this one, this will be x minus 1. So here when you will write interval of differencing is 1. So E inverse upon x will be x minus 1. Fine. So this will be 6 plus 6x minus 6. So this will cancel out this. So in both ways the result is same, whether we write it this one or whether we write it this one. Both way result comes out to be 6x, and here also result is 6x. So I have shown you whether you write it this way or this way, but this cannot go, operand cannot go separately in the numerator and denominator. This is not possible because this is the two operators operating one by one upon the operand. Operand has no freedom to distribute itself separately in the numerator and denominator. So that is why we have written it something like, and didn't write it like that. This question is separate question. In the question it is in itself given that this operand is for delta square, which is in the numerator, and this x cube is for the e, which is in the denominator. Now we cannot write it something like this one, that this cannot be written that this we will take common and you will write. No, this way it could not be done. Now it is given in the question, both are separate. This is in the numerator, this is in the denominator. This is the operand of delta square, this is the operand of e. So we cannot take the common, we have to do it as such in the examination if it is given. So we have to calculate these two things separately and then put the value. And if we are given this one, then we have to apply the operator 1 by 1 upon x cube. We cannot distribute them in the numerator and denominator. So this is the biggest difference between these two questions, and that is why I have taken these two questions separately, so that I can make the idea concept clear in mind. Because sometime in very short answer type of compulsory question this question comes, so I have taken this question. So now we will try to find the value of this part number B. So I'm going to write, now I'm going to write it as delta square x cube divided by e x cube. Now let me first calculate this value, and this value will put it over here. Now delta square x cube can be written as delta x cube, fine. And this can be written as 1 is interval of differencing x plus 1 cube minus x cube, fine. This will be delta x plus 1 cube, when opened it will give this one, fine. This will cancel out. This will be 1 plus 3x plus 3x square. So this delta will be distributive. 3 will come out. This 3 will come out. Done. A delta of a constant is 0. 3, it can easily be written as x plus 1 minus x of 3. It can be written as x plus 1 whole square minus x square. Done. This x to x will cancel out. This will be 3. Fine. 3. Open the square, x square plus 1 plus 2x minus x square. Done. This x square to x square will cancel out. This will be 3 plus 6x. This is nothing but 6, and it is x plus 1. This implies that we have calculated delta square x cube is equal to 6x plus 1. Done. So I am going to substitute this value over here. It is 6x plus 1. Now next we are required to find e x cube, shift operator upon x cube operand. So let me try to do it. E x cube, fine. What it will be? It will be is equal to x plus 1 cube, fine. So I'm going to put it, substitute this value over here, because you know that you can write it over here. You know e of f of x is equal to shift in the forward direction, and here h is 1 and f of x is nothing but x cube. So it will be e of x cube will be x plus 1 cube. Okay, so now this will cancel out. So this will cancel out, and this will cancel out. It will be x plus 1 whole square. So this will be 6x plus 1 whole square. So this implies that delta square x cube e x cube is equal to 6 x plus 1 whole square. So this is the required result. So in both the problems the answers are different because the problems were different. So I have also explained you how to identify the problems and how to do them. So this question is very important from examination point of view. Now we will take the next problem, the last problem, based upon the properties. So the statement of the problem is, so this is the next problem, and in this problem we have to prove that this quantity is equal to e raised to the power x, where interval of differencing being unity. So we have to take the left hand side. So let us take left hand side, which is delta square e raised to the power x into e raised to the power x delta square e raised to the power x. We have to calculate this one and this one. We will calculate them separately. So let us first calculate delta square by e raised to the power x. So I will write it as delta square e minus 1. You can write it both way. You can write delta square first then e minus 1. It is up to you. So I have chosen this one. Delta square e minus 1 is x minus 1. Okay. This will be e x e raised to the power minus 1. E raised to the power minus 1 is a constant quantity, so this will come out. So inside we are left with delta square e raised to the power x. So we know that how to deal with e raised to the power x and delta square. So this will be e minus 1 delta. This will be e raised to the power x plus 1 minus e raised to the power x. Using the definition of delta, function is e raised to the power x. In place of x, I am going to write x plus h, which is x plus 1, because interval of differencing is unity. So this will be e minus delta. E raised to the power x is common. Inside we are left with e minus 1. This quantity is again constant because e is a quantity which has values 2 point something like. So this will be e minus 1 delta e raised to the power x, and this is further equal to e minus 1 by e. Can I write it because this will go into the denominator and become positive, power will become positive. This can be written as ex plus 1 e raised to the power x. This thing is further equal to e minus 1 by e. E raised to the power x is outside. This is e minus 1. So this is e minus 1 whole square by e into e raised to the power x. So I have calculated this one. Now let me calculate this one also. So this is e raised to the power x divided by delta square e raised to the power x. So now let me calculate. This is e raised to the power, shift is ex plus 1, and delta can be written as delta e raised to the power x. You know e raised to the power x dot e. Delta, you have calculated delta e raised to the power x is nothing but e raised to the power x e minus 1. So here I am going to write it as ex e minus 1. Fine. So this e minus 1 will come out e minus 1 into e raised to the power x divided by delta e raised to the power x. Once again it will be e minus 1 e raised to the power x divided by, it will be again e minus 1, and e raised to the power x. Fine. This e raised to the power x will cancel out. So we are left with e minus 1 whole square. So using this 1 and say 2, this one in over here, we will get delta square e by e raised to power x is this quantity. So I am going to write it over here. This will be e minus 1 whole square e raised to the power x divided by e into this quantity, which is e by e minus 1 whole square. This will cancel out, e to e will cancel out, so we are left with ex, which is nothing but equal to right hand side. So we have proved the result that we have to prove that this was equal to this one, where I hope that I will be able to clear the concept in your mind. And in this video lecture we have taken 3 problems, and all the 3 problems are very important and based upon the properties of the various operator that we have studied so far. So that is all I have from this lecture, and very soon I will be with you with my next video lecture. Till then, take care, bye bye, and see you soon.